Okay, let's look at example 6.3. This example will help us understand why I prefer this method. But there is a huge caveat in that. So this example is asking us to determine the forces in members FH, GH, and GI. So that was not what I expected. In this member right here, this member right here, and this member right here. Okay, so it's a very specific section that we have to find the forces in, and that makes our life a lot easier. It means that we can do some things easier. So what we're going to do is we're going to do the method of sections, and we're going to come in here and we're going to draw a line through here, and we're going to create a free body diagram through there. But what is the first thing that we need to do with all these problems? So the first thing we're going to need to do is we're going to need to find the unknowns, here and here. But in this case, I'm going to cheat a little bit. So I'm going to draw this section. So do I want to deal with this section over here, or do I want to deal with this section over here? Well, this one over on the right just looks easier. It's just like less stuff. And so I don't even have to ever find out the value at A. So I'm going to say, you know what, let's take the sum of the moments at A is equal to 0. Because we have a force here, right? Or my kind of lazy free body diagram, sorry, is going to force at L. So what do we have? In this case, we have 1 times, each one of these segments is 15. So 1 times 5, or sorry, it's 5, not 15, plus 6, or plus 5 times 5. So that's adding this force and this force. Now I'm just going to add them all up in one. It's the same thing, but it's going to be plus 6 times 10 plus 6 times 15. Now we're just down to 1 plus 1 times 20 plus 1 times 25, and that's going to equal L times 30. And that gives us that L is equal to 7.5 kilonewtons up. Okay, so this is equal to 7.5. Okay, so now we know L is no longer an unknown. So now let's take our segment and let's draw our segment. Okay, here we have at H, we have, see if I can draw it somewhat to scale here. Here, there's a little segment here. Then there's a segment here. And now here's the important thing, is I have a force here of 1 kilonewton. I have a force here of 1 kilonewton. I just figured out this force, so it turns out I didn't draw it to scale very well. Oh well. Of 7.5, right? And then I cut through these members. And so what happens when I cut through a member? Well, I'm going to replace it with unknowns. This is GI. I have a force coming off here of GH, and I have a force coming off here of FH. So now it's a relatively simple problem, right? I just have 3 unknowns, one equation with 3 unknowns. Okay, so the first thing I'm going to do is I'm going to take the sum of the moments. I don't know, where did I take the sum of the moments? The first one I took the sum of the moments at H, this point right here. Why this point? Well, because then now GH and FH go away. So I can say sum of the moments at H is equal to 0. Okay, so here at H you have 1 times 5 is this one right here, right? And then it's going to be minus 7.5 times 10. Now I'm going to have this, so the 1 is making it, so it's going to be plus GI times that distance. Well, what is that distance? Let's come and look at this triangle. This triangle is the overall triangle from here. Let's look at this triangle. This is, so I'm going to draw that triangle right here, right? We have this triangle. This is 8, and this is 15. This works out to be 17. Okay. Now, I could go through and I could figure out the angles, and that's how they do it in the book. But quite frankly, I know I'm going 2/3 of the distance, right? So I can say this distance is 2/3 of 8, because that's what similar triangles is going to tell me, right? And so this is going to tell me that GI is equal to 13.125. And that's going to be a positive number, so therefore positive tells me nothing. Again, please don't get hung up on positive or negative telling you anything. It just means that I drew it in the right direction, and I drew it in the direction of tension. So that's going to be in tension. So GI is 13.125 in tension. Okay, now let's pick another place. And you'll notice, well, you'll find that there's all sorts of places that you can do stuff. You can take the sum of the moments anywhere you want, right? But here, if you follow this down, there's another intersection here, right here, and this is point G, right? So if I take the sum of the moments at G, the nice thing about that is what? Well, GH and GI are going to cancel. So let's just do that. Let's say sum of the moments at G is equal to 0. Well, in that case, you're going to have 1 times the distance from there is going to be 5, plus 1 times 10, minus 7.5 times 15, right? Those are the known forces. And then we also have FH. But now we have to account for the x and the y components of FH, right? So we have plus, I'm going to carry this on to the next line. Sorry, I didn't give myself enough space. FH in the x direction times this height right here, right? The x times this height. What is that height? Well, we just figured out it's 2/3 of 8, right? So I'm just going to again write it 2/3 of 8. Now, did I give it the right sign? This is going to be going in, this needs to be a negative on here because it's going to be going in the same direction as this one right here. And then the y is going to be also going to be minus FH in y, and this is going to be times this distance, which is 5. Okay, and this is equal to 0. So, but we know FH and x is what? Well, it's going to be, we figured out this triangle over here, right? It's going to be FH times the x. It's the same triangle, so it's going to be 8/17, and FH in x, that's y, yeah, that's y, and x is going to be FH times 15/17. So when you plug this all into this equation, you end up finding that FH is equal to minus 13.8125. Okay, minus telling us that we drew the arrow in the wrong direction. So since it means that it's FH is 13.8125 in compression. Okay. So now we know 2 out of the 3. The last one we need to figure out is GH. Now, in the book, they go through and they pick another place. I think they take the moments about this point right here to find GH. That seems, honestly, to me, a little bit unnecessarily difficult. I'm just going to take the sum of the forces in X or Y, and I'm going to pick Y, kind of arbitrarily. So I'm going to say, let's just take our sum of the forces in Y is equal to 0. Well, what do we have? We have FH in Y. We'll put in those numbers in a little bit. Minus 1 plus 7.5, right? And then I drew GH down this way, so it needs to be minus GH in Y is equal to 0. Okay, so I can put the GH on the other side, right? So GH in Y is equal to 7.5 is 5.5 plus FH in Y. Okay. Now here's where you have to be a little bit careful. So, and quite frankly, I have to admit I made this mistake when I was going through and working this out in advance. FH and Y is FH, we figured out right here's FH, and it's going to be times 8/17. So FHY, we looked at it right here, right? So it gives you 6.5. Okay. The problem is that it's 6.5 in which direction? Well, if you're going to stick with the arrow that we drew up and to the left, that makes sense. But then you need to use this negative number. You just have to be consistent with it. What you're going to find is this needs to be, so GH in Y is going to be minus 1.0. And if you are not careful, you're going to add them together. You're going to end up with getting 12, and you're going to get a wildly incorrect answer, right? Since this number, so if you want to mentally just redraw the arrow down like this and take care of it like that, I understand that's not unreasonable, right? But you drew it up in this direction, so just you got a negative number, so you stick with the negative number here, which is how you get this needs to be right here, that needs to be a negative. Okay, so now GH and Y is 0, and then you have to redraw another triangle. Here we have this triangle. This height is what? It's 2/3 of 8, right? This distance is 5. This ends up being like you can figure out the angle of this. I did the similar triangles. It ends up being like 7.31. And so GH ends up being minus 1.371. So therefore, it means we drew it in the wrong direction, which is fine. So, and since it's going into it, GH is 1.371 in compression. And that's your problem. So you found the three members. So it's much fewer steps than when you're going through and figuring out each individual element. Now, quite frankly, you can use this process to figure out each element in every single thing. You just have to cut a whole bunch of sections. But at that point, it's not really saving you anything over the method of joints.